Okay, so today we're going to discuss the second section of chemical composition and look at a major part of chemistry called the mole. No, it's not the animal. Okay, so we've talked about using AMUs as a way to relate number of atoms to some sort of mass, and we called that atomic mass. But if we want to be practical in a lab setting, AMUs just aren't convenient. They're really small. No scale is going to measure that amount. We're not going to use that amount in a lab. And so we need a unit that's more convenient. And so grams really work the best. And so we need a way to now take our atomic mass that's in AMU and relate it to grams. So let's say we have 26.98 grams of aluminum, and we want to know how many grams of copper are needed so they both contain the same number of atoms. Well, we can use the average atomic mass. We know based on looking at the periodic table that the average atomic mass for aluminum is 26.98 AMUs for every one atom. And we know also by looking at the periodic table that the average atomic mass of copper is 63.55 AMUs in one atom. And so we can see that copper has a larger mass per atom, which means that copper atoms are going to weigh more than aluminum atoms. So if we want the same number of atoms, we're going to have less grams of copper because they each weigh more. Okay, so to have the same number of atoms, the copper pile is going to weigh more because each copper atom weighs more. Got that backwards. Okay, so if we look at having the same number of atoms, the 26.98 AMUs and the 63.55 AMUs, well, 26.98 grams of aluminum and 63.55 grams of copper will have the same number of atoms. And so basically we can this is how we're going to relate grams to AMUs. Okay, so we can count things in AMUs, or if we just change the unit to grams, they're still going to have an identical number of atoms. Okay, and so this brings up the mole. To abbreviate mole, we just use MOL, so we're just dropping the E. And the mole is the number equal to the number of carbon atoms in 12.01 grams of carbon. We just use carbon as kind of our base measurement to define the mole, and that's the element that we're going to use to define that. This number is equal to 6.022 times 10 to the 23rd, and that is what's called Avogadro's number. Avogadro was a guy who did a lot with chemistry, introductory chemistry. So 1 mole of something consists of 6.022 times 10 to the 23rd units of that substance. And so we're taking Avogadro's number and relating it to 1 mole. So 1 mole is a ton of whatever. 6.022 times 10 to the 23rd is quite a large amount. And since atoms are so small, this kind of works because we're usually going to have a large number of atoms. This is kind of like saying that 1 dozen is equal to 12 units. And so we can say that 1 mole is equal to 6.022 times 10 to the 23rd units. So it's kind of like saying a dozen, only it's just a different quantity. Okay, so if we have a mole of eggs, we have 6.022 times 10 to the 23rd eggs. If we have 1 mole of water, remember water is composed of H2O molecules, so we'd have 6.022 times 10 to the 23rd H2O molecules. If we have 1 mole of carbon atoms, then we have 6.022 times 10 to the 23rd atoms of carbon. Now, if you remember what we just talked about relating AMUs to grams, based on the periodic table, we can also say that that is equal to 12.01 grams of carbon. And so here we have 2 new conversion factors, moles to atoms, and then moles to grams. And we're going to be using these to convert between all 3 of those units. If we look at hydrogen, for 1 mole of hydrogen, we have 6.022 times 10 to the 23rd atoms of hydrogen. And again, if you use the periodic table, that is equal to its atomic mass, which is 1.008 grams of hydrogen. So a sample of any element that weighs a number of grams equal to the average is equal to the, let's start over. So if you have a sample of any element that weighs a number of grams equal to the average atomic mass of that element, it's going to contain 6.022 times 10 to the 23rd atoms for 1 mole of that element. So atomic mass equals Avogadro's number, which equals 1 mole. Okay, let's try an example. So let's say we have this pile of hydrogen atoms, because who wouldn't have that laying around? And we want to know the number of moles of hydrogen and the number of atoms in that pile. So we're going to count by weighing. Remember, we are relating this to atomic mass, which gives us the number of grams in 1 mole. And so our mass of our pile is 0.500 grams. We know that 1 mole of hydrogen is equal to 1.008 grams. This comes from the periodic table. Okay, that's our average atomic mass. Instead of AMUs per atom, we're now doing grams per mole. Okay, but it's the same idea. And we also know that 1 mole of hydrogen is equal to Avogadro's number, which is 6.022 times 10 to the 23rd atoms of hydrogen. Let's see if okay. So let's start with our 0.500 grams of hydrogen. Now I'm going to break this down into 2 steps, but then I'm going to show you how to kind of put the 2 steps together, because we have this kind of process. So if we take a look at kind of how we can convert and use our conversion factors, if we're starting with mass, okay, really the only place we can go initially is to moles. Okay, and we can do that through atomic mass. Okay, and then from moles, we can go to number of units or particles. So right now, all we've talked about so far are atoms. And so we can convert to atoms by using Avogadro's number. Okay, and so here are our 2 conversion factors, and this is kind of the process for how we're going to use them. So if you want to go from mass to atoms, you must go to moles in between. Okay, and so we can put this all into one big step. I'm going to show you how to do each part, and then we'll put them together. Okay, so if we're going to start with grams, here's our dimensional analysis. We know we want grams on the bottom, and we know a direct conversion between grams and moles, and so we know we want moles on top. Well, based on the periodic table, okay, so the average atomic mass is 1.008 grams for every 1 mole of hydrogen. So that was this conversion factor. So if I wanted moles, I would just stop right there. Okay, so let's calculate this. Remember, anything on the bottom gets divided, anything on the top gets multiplied, so it's 0.5 divided by 1.008. Okay, and so that's equal to 0.49603 moles of hydrogen. And so if I look at significant figures, I have 1, 2, 3 significant figures. I want 3 in my answer, and so that equals 0.496 moles of hydrogen. If I just wanted moles, I could stop right there. Okay, but remember, if I'm trying to go all the way to atoms, I don't want. If I wanted to go to atoms from moles, then I would start with my mole amount and just go to atoms. But I'm going to show you how to go from grams to atoms. So I'm going to start with my 0.500 grams of hydrogen. First, I need to go to moles. I know for every 1.008 grams of hydrogen, there is 1 mole. And now that I'm in moles, I am here, and I want to go to atoms. And so I know, based on this conversion factor, that for every 1 mole of hydrogen, there are 6.022 times 10 to the 23rd atoms. And so if I take 0.5 divided by 1.008 times 6.022 times 10 to the 23rd, okay, that should give me my answer. If I do all that, I get 2.9871 times 10 to the 23rd. I have 3 significant figures in my problem, so I want 3 in my answer. And so that becomes 2.99 times 10 to the 23rd. Don't forget units, atoms of hydrogen. And so I'm using 2 steps to convert from grams to moles and then to atoms. If I wanted to just go to moles, I would just do this first part, and this would be my answer. Okay, so Try a couple of these on your own. Take 10 grams of aluminum, find the number of moles, and find the number of atoms. Remember, for every element, 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd atoms. And then make sure you use the periodic table to find the average atomic mass, which is the number of grams in 1 mole. Okay, so try this example on your own, and here's the answer so you can check your work, and we'll go over it in class.